Hey, meet square root of 2. He comes from the diagonal of a unit square. So far we've learned about numbers that are ratios of integers. We call such numbers rational numbers. But if we ask the square root of 2 to represent himself as a ratio of two integers, do you think he can? He's tried a lot, but so far, no luck. So, is the square root of 2 a rational number? Instead of trial and error, let's assume that the square root of 2 is a ratio of two integers p and q, where q cannot be 0. So the square root of 2 equals to p by q. Great. Now, all we need to do is find p and q. This brings us to another property of rational numbers. Take 1 over 2 for example. 1 over 2 is a rational number, so is 2 over 4, and 3 over 6, and so on. All these numbers are different, yet they represent the same quantity. And all of these numbers, 1 over 2, is the simplest form. This means we can reduce 2 over 4 and 3 over 6 both to their simplest forms, that is 1 over 2. So every rational number has its simplest form. And when a number is in its simplest form, its numerator and denominator have no common factors. Now, let's go back to our equation. The square root of 2 equals p over q. Apart from what we know already, let's assume that p over q is in its simplest form, which means p and q have no common factors. So let's find p and q. Squaring both sides gives us 2 equals p squared over q squared. This can also be written as p squared equals 2q squared. This is our first equation. In this equation, p squared is a multiple of 2, which means it's an even number. And if p squared is an even number, then p should also be an even number. Otherwise, it would not be an even number when squared. So, we know that the integer p is even. Let's assume p is equal to 2 times k, where k is the integer we need to find. Substituting the value p equals 2 times k in equation 1 gives us 2q squared equals 4k squared, which can be simplified further to q squared equals 2k squared. This is our second equation. From this we learn that just like p squared, q squared is also even. This means q is even too. Wait a minute. If both p and q are even, it means they have a common factor and that the common factor is 2. But when we started out, we assumed p and q have no common factors. Did we make a mistake along the way? No. This only means our assumption was wrong. And that means that the square root of 2 cannot be a rational number. There are many numbers other than the square root of 2 that are not rational numbers. We group them separately in another set of numbers called irrational numbers. Well, square root of 2 is happy now that you know him. Thanks for listening, he says.